In this video, we're going to take a look at how to implement Koin into an Android project, and we're going to consider it along with the solid principles of object-oriented design. So why do we want to use Koin? Well, it's an injection library, a lot like Spring or Spring Boot would be, where we can define our objects like our view models in one place and use them in multiple places. So let's consider this along with the solid principles of object-oriented design. Single responsibility means each class should do one thing and do it well. Open-close principle means every class should be closed for modification but open for extension. Now the last three is what we really see implemented in Koin. Liskov Substitution principle means that any subtype should be substitutable for its supertype. So in other words, we can define an interface in several classes that implement that interface, and objects of those classes that implement the interface can be substituted or stored into a variable, where the variable type is the interface type. Same thing with superclass and subclass. You should be able to create a subclass object and store it in a variable of the superclass type. Indeed, this works well with interfaces, and the interface segregation principle says that a class should not be required to implement any functions that it doesn't need to implement. In other words, interfaces should be very specific. In this video, we're going to focus on instantiating a view model through Koin for our Android application, and that's not going to use an interface. However, I am going to have a part 2 video that follows this, where we do look at the Liskov substitution principle and interface segregation principle by creating an interface in our service layer and using Koin to instantiate an object of a class that implements that interface and stores that object into a variable where the variable type is the interface itself. And finally, dependency inversion is probably the most related to Koin because it essentially says that we should be able to use dependency injection, which is where we can assign a variable based on a dependency container, where in this case Koin is our dependency container. Koin is where we put our object definitions, and then those can be injected into variables using Koin's language. Additionally, Koin gives us something called an Android logger, which we can use for logging. So a few steps that we need to set up, and we'll walk through these. First, we need to add any dependencies to Gradle. Then we need to create an application class and register that in AndroidManifest.xml. And then we define the classes from which we want to make objects in something called appModule in a module definition. Let's jump right in. We'll start by adding a dependency to build.gradle. I'm adding Koin Android 3.14. As always, this is the latest at the time I'm recording this video, but it might not be the latest at the time you're watching the video, so I recommend just look for the latest, grab it, and then add it and go ahead and refresh. One other dependency we need to add feels a bit unrelated, but we want to add com.squareup.okhttp3:okhttp:492. That version or something more recent, if something more recent is available. I find if I don't do this and I'm using Koin with Retrofit, I get a very strange error that says expected Android API level 21 plus, but was 30. And actually, I think it might be on the Retrofit side since this is OKHTTP. But nonetheless, let's go ahead and add that now. After that, let's take a look at the Android manifest. Android manifest defines an application, which is essentially a class that starts our application. And for Koin, we want it to be in the global context in this case, which means essentially it's globally available. So what we're going to do is override the default application class for Android and then override a specific onCreate method in there. And inside of that, we will put our Koin startup definition. Then we'll take that overridden class and we'll essentially register it here in our Android manifest. So let's start by creating that main class. I'm simply going to say new Kotlin class, and this is my plant diary, so I'll call it my plant diary application. And notice I'm just putting this out essentially at root. Now I'm going to have it extend from the application superclass, which is the one we're configuring by default in that Android manifest. So see here, just like our solid principles of Liskov substitution and everything else we're seeing, we're making a subclass type that can be substituted for the superclass type in our Android manifest. So we have our application, and now we need to override onCreate. I simply start typing on create, and Android Studio gives me a hint. It says, hey, I think I know what you want to do here. Let me help you out. Now, inside of this, I'm going to start Koin within the global context, which here again means it's essentially globally available within our application. I start with the global context object, and then I invoke a startKoin function, take care of the import. In here, just a few lines we need to do to get things started up. We say Android logger, and take care of some imports, and effectively we're giving it different logging levels based on whether we are in debug or in production. Next, we're going to set the Android context. Now, if you're used to Android programming, you might know what the context is. If you're not, here's what it is. It's essentially an object that tells us about our application. We can find things like where our storage directories are on the SD card or within the device itself, and anything else about the application like its package name or anything like that. So we need to set that context, and we'll do it like so. Import Android context, and then we simply pass a reference to our current object. Next, we need to load our modules. Now, we haven't defined our modules yet, but we will do that in just a second. So let's say modules, and then we're going to pass it something called appModule, which is a variable that we've not yet created. So that's our next step. Let's create the application module. So still here at root directory, I choose new, and then I say Kotlin file. And I'm going to call this one appModule. Now, we don't need a class here because we're just essentially assigning a variable. So I'm going to say val appModule equals module. Open curly, close curly, go ahead and resolve imports. Inside of here, we can declare any classes that we want Koin to manage object instantiation for. So we'll say ViewModel, main ViewModel. Should be a lowercase m. Import and import. Now, let me connect a few dots and allow me to explain a few things, because we see module here, we see something called ViewModel, we see something called main ViewModel. Main ViewModel is this class right here, which we wrote a little bit ago. Right now, it just has a bit of live data in it, but essentially, we're declaring this main ViewModel, or we're saying that this is a class that we can create an object out of, and we're doing it within the ViewModel scope. Remember that, we'll come back to that in just a moment. We're declaring that all within this, essentially this module function, and assigning it to the appModule variable. Now let's go back to that application class that we made just a moment ago. And you see now that appModule variable that we declared over here has been resolved. So that's the part I said we'd come back to. Sure enough, you see now it's been resolved. One more thing we want to do, and then we're going to go take a look at some definitions. Let's go back to our Android manifest, and let's say instead of using the default application, we want to use this extension of the default application, which knows about Koin. Easy to do. You notice right now we don't have an Android name set in here because we're just using the default application class. But as soon as I say Android name, I can specify a more specific extension or subclass of that, and that's my plant diary application. When our application loads, it's going to jump down to this My Plant Diary application class. It's going to go ahead and do all the work it normally would have done in the superclass, and then it does this work to start our Koin context, which includes reaching into appModule and looking at what we have registered here within our module definition. Remember, once again, ViewModel is a scope. Let's go take a look at some definitions. Most of these I've already described, so I'll just put this slide here so you can pause if you want and take a deeper look at the definitions. Global context, default context for Koin, a singleton that holds the Koin instance. startKoin, that's in our application class, that's where we start the Koin container. Module, a logical grouping space to gather our Koin definitions. Koin.properties we didn't look at and we aren't going to look at. That's just a properties file that we can use to set any properties we're going to use. Android context, we know that tells us a little bit about our app specifically, like it's sandboxed within the SD card. So that's what we need to define the classes that we want Koin to manage. Now, if we want to create objects out of those classes, we have a couple of options within our Kotlin class files. One is by inject, which is a lazy evaluation, which means Koin will go out and create an object only when needed. Where get is an eager fetch, where if we assign a variable equals get, then Koin is going to go ahead and instantiate an object out of that class type right away and assign it to us. So just a subtle definition. We also saw that concept of scope, and we know that within Android we have a special scope called ViewModel, and more on that in just a moment. But there are a couple of other scopes that we can use for non-ViewModel classes, things like a service class or a data class or anything else we might want to instantiate. One of those is single, which means it's only going to create a single object instance and reuse that single instance whenever needed or whenever called upon. This is analogous to a singleton class or a singleton object where only one is created. If you saw my video on Retrofit, we had a similar concept there where the Retrofit client instance is essentially a singleton object. Only one is created throughout the entire life of our application, no matter how many times we assign it. Now, factory is a different scope, and factory means it's going to create a new object each time we're invoking a get or a by-inject function to get that object. We can also have a couple of specific scopes, which I'm not going to use in this example, but we can scope to a specific activity. We can also give a more specific scope that we name, but for our purpose, single, factory, and ViewModel are going to be the most common. Definition on a couple things that we've already seen. There are also ways that we can pass parameters in to an object that we're instantiating, like constructor parameters we can do simply with get, or if we need to set properties, we can also do that with a set properties call. Now the ViewModel I talked about a little bit more. So ViewModel is a special scope that we use in Android that's a little bit of singleton and a little bit of factory put together, but it's really meant to manage this ViewModel concept, where a ViewModel is usually associated with some kind of view, like an activity or a fragment. And the ViewModel essentially handles the state or the data for that view. So oftentimes a ViewModel will have live data, which is something the view can observe on. Oftentimes the ViewModel will also hold data that we collect from the user interface. So these two are closely intertwined, and also a ViewModel needs to be lifecycle aware. It needs to know about when the application is started, when it's paused, when it's gone in the background, when it's been destroyed, so on and so forth. And that's one of the nice things about both a ViewModel and the ViewModel scope. ViewModels can be associated with a single activity, which is where we'll tend to use get ViewModel or by ViewModel, but ViewModels are also really handy when we share them across activities. In other words, imagine having different screens in your application, but all of the screens point to the same data model. So if you switch from one user interface to another, you're only changing that user interface. You're not changing the ViewModel behind it that holds all the data. This saves us a lot of time over the old ways of programming Android, where we had to pass things from one activity to another by using a bundle. So if we want to have a shared ViewModel, we'll simply invoke bySharedViewModel or getSharedViewModel functions. I'm back now in our main activity class, and let's see how we would do this. First, we can simply go up to the class and don't need to be in a function, but let's declare a variable for our ViewModel. So remember, activity is the user interface that the user sees, and now we're reaching down into our stack where we can look at our state, we can look at data, we can look at live data, so on and so forth. So this is connecting us all the way from user interface to persistence through the ViewModel. So let's declare a variable of type ViewModel. Now let's use that Koin syntax that we just saw. It doesn't know what I mean by ViewModel here, so I'm going to give it a little bit of help. It's not suggesting an import for me, so I'm going to go ahead and enter it myself. The org.coin Android X ViewModel ext Android ViewModel. Still one more issue it has. When I mouse over, it gives me an error that it doesn't know what set value is, and I realize I made this a var where I really should make it a val. So essentially, once assigned, it can't be reassigned because we're having Koin do the assignment anyway. So I take care of that and the error goes away. Now I'm ready to test things out and see if we're actually able to get data all the way from our DAO to our service to our ViewModel with live data and all the way into our activity class. I won't put it in a user interface class just yet. I just want to set it in the debugger and make sure that everything is working. So down here in the onCreate function of my component activity, I'm going to say ViewModel.fetchPlants. And let's remember what that is. We can pop in quickly, and we can see that that's going to start a coroutine that we wrote in an earlier video. That coroutine is going to go find a JSON data source, and it's going to use Retrofit to parse that data and populate a live data object called plants. So that means back in our activity, we can observe on plants. And we can do it an interesting way with Compose. We say ViewModel, which is our, of course, object above. Now, plants is our live data object, and then we can say observeAsState. ObserveAsState is a function that was essentially defined for Compose, where we can take an observable, observe it as a state, and a state is what we pass to each of our composable functions. It's essentially the data we pass to our composable functions, and then we tell them to draw the user interface. So we need to give this an initial value, and we'll simply say empty list. That means what's it going to be until we hear back from the live data. We'll take all of this and save it into a variable. So val plants. Now, word to the wise, be very careful here. It feels like you want to do an equals or assignment operator, but here we actually want to put in the word by, by. Reason being that this observeAsState will take whatever gets returned from this plants live data object, which is a list of plants, and it wraps it within a state object. So by effectively handles that state and just returns to us a list of plants. I have accidentally put in equals instead of by numerous times, and every time it cost me a lot of time to figure out what in the world I did wrong. Also, by the way, just so you notice, I made a spelling error. I paused and fixed it, but initial, I've now spelled that correctly. I do have one more issue, though, which is observeAsState is not recognized. So I need to add one more dependency to my build.gradle. I'm going to go right where I have my compose imports, and I'm going to add AndroidX.compose.runtime:runtime live data, and then compose version, which is the variable that I'm using to keep all of my compose dependencies at the same version. Let's go ahead and do a sync now, and then check back. It now realizes what observeAsState is, and Alt-Enter will fix it, and we have our import for observeAsState. So at this point, we've wired up our activity to our ViewModel, and we want to validate that we are able to view the data in our activity that's retrieved from our ViewModel's live data, which down the road is actually retrieved from a data source. So what we'll eventually do is take this plants state object and pass it into our composable functions down below. For the moment, let's just kind of do a dummy assignment so that we can view this in the debugger. I'll say var foo equals plants, and that'll let me set a breakpoint. And then var I equals 1 plus 1 will let me step just beyond that breakpoint so that we can witness the plants being populated. I'll set a couple more breakpoints here that we can look at. The activity is going to invoke fetch plants on the ViewModel, and that's going to kick off our coroutine here. So I'll snap a breakpoint where the coroutine starts, and another breakpoint within the coroutine once it has started as well. With all of that ready to go, now I can start my application. The AVD is starting to draw our application, and we see that our first breakpoint has hit where it's calling the observeAsState. So I'm going to tell it to continue. Now, fetch plants, let's go ahead and hit continue here, and we'll see it walk into the fetch plants function. First, it's going to attempt to launch the coroutine. I'll simply do a step over. Now you notice when I do the step over, it walks into our coroutine. So I'll go ahead and press play, and now we're back to our activity, and it's attempting to assign this plants variable to a value. So we see right now we don't have a whole lot going on with plants, but remember this is something we are observing. So once plants is filled with data, we should see this get called again, and we should see data. So I'll go ahead and continue. And we can see over here that our screen has rendered. Now back to our activity. And take a look now at this. So you see it kind of, you probably noticed that it did a couple of calls in here. But remember, we're saying we're observing on the data. We want to be notified when the data changes so we can update our user interface. So that's why you saw it maybe go through once and then go through a second time. But take a look at this now that we're here another time. Look at this variable foo, and we can see that we're simply assigning our plants collection to it. Look at what's in this variable foo. Whopper red with bronze leaf begonia, dwarf fireweed, alpine bartesia, Several things that are plants. As a matter of fact, we have 5,950 plant objects stored into this variable. I'll go ahead and choose continue. We're not using the data in our user interface just yet, but we will do that in a very soon to come video. We simply want to link everything together. And indeed, if we go back to our class diagram, we can see how it all does link together. We have our app module, which we've now created, which starts up our Koin modules. We could also add in here that My Plant Diary application class, which kicks everything off. Now look at this. This is what we've wired up, this line right here. We have our activity, which shows the user interface. It's wired up to a ViewModel. In a previous video, we wired this up to a plant service, which we wired up to iPlant DAO, which we wired up to Retrofit client instance, and that's what goes and fetches our data, passes it back to the plant service, which makes it available via live data via the ViewModel, which now our activity can observe on, and we see sure enough, when the live data updates, our activity updates with that live data as well. A big advantage of that is if you watch during the debugger, I could show the screen and collect user input as I'm loading data. Ages ago, we used to have splash screens or loading screens in applications where we would try to go fetch some data and we would essentially hold the user until the data comes back. But now with all this magic of live data, we can go ahead and draw the user interface and be responsive on that user interface while we're fetching data, and then we can update the user interface once we have fetched the data. So this video has been a look at Android and how to set it up with Koin and how that relates to the solid principles of object-oriented design. As always, I hope you found this video helpful. I will push the source code out to GitHub, and I look forward to reading your comments. Thank you.